Hello students, welcome back. Previously, we went through the limit concept and notation through a graphical approach. We're going to consider the other two approaches later. For now, let's stick to the graphical approach. We went through this example previously. Remember? We have two bad points, x equal to -4 here and x equal to +3 there. These two numbers separated the number line into three pieces. So we have these three intervals in which our function f is continuous, and three intervals here correspond to three curved pieces. This one here, and the middle one, and the third one. And then also explain why. Well, that explanation requires a limit computation. It's not really a computation, it's just reading a graph in any case. There you go, here's the answer key. And the function value and the limit value are all the same, then yes, continuity, but in these cases, no. Both are discontinuities. 3 is different from these, and here we have 1, and then we have all different values. Anyway, there you go. Okay, so much for the review. Now let's go to the next example here. And what's the big difference this time? Well, this time let's discuss asymptotic behavior. What if we have an asymptote? Let's discuss the vertical asymptote first. F of -2, right here, function value. Well, I don't see anything here, so that's undefined. F of 1, again, nothing here, so that's undefined as well. If there were a dot here or something, or there, or whatever, then you can give that y-coordinate value, and that's your function value. There you go, but I don't see anything here, so both are undefined in this case. Alright, now how about the limits? The left-hand side limit, as I approach from the left, versus the right-hand side limit, as I approach from the right. Which is left and which is right? Well, this negative sign there and positive sign there, this negative sign here and the positive sign there, that makes the distinction. Remember, in mathematics, negative is to the left, positive is to the right. So 2 minus, 2 plus, 1 minus, 1 plus, they mean the left-hand side and right-hand side. Okay, let's follow the graph from the left-hand side and also from the right-hand side to answer this question. Following the graph from the left-hand side, clearly this is going to positive infinity. Now following the graph from the right-hand side, that's going to negative infinity. So what do we have as the limit value? We have two different infinities, so this is undefined. Let's elaborate this. To the left, that's going to positive infinity, and to the left, to the right, the limit value is negative infinity, and there are two different infinities, so the limit is undefined. Okay, how about the next problem here? So 1 minus, that's the left-hand side. So following the graph from the left-hand side, clearly going up. 1 plus. Following the graph from the right-hand side, that too goes up to positive infinity. So what can I say about this limit? That's positive infinity. Same infinities either way. Left-hand side, right-hand side, both are going up. Let's elaborate this writing. So that's positive infinity. And then that too is positive infinity. Graph is going up. And same infinities there. So the limit is positive infinity. So these two are the same. So the limit exists and the limit is positive infinity. The limit value does not have to be a real number. It can be an extended real number. So for vertical asymptotes, please expect either positive infinity or negative infinity. And when they're different, then we may end up with undefined limit. But if it is one-sided, then typically you'll have to get either positive or negative infinity. Alright, so much for the vertical asymptote. How about the horizontal asymptote this time? Clearly you have this horizontal behavior here, horizontal asymptotic behavior there as well. And in mathematics, left-hand side is negative side, right-hand side is positive side. Remember that? So this limit here, limit as x is going to negative infinity, that's the left-hand side. Limit x is going to positive infinity, that's the right-hand side. Now, as I move to the right, or as I move to the left, what happens to the y-coordinate? Because the function value is y-coordinate. Well, let's answer those using the graphical approach. So, to the right, we see horizontal asymptote y equal to 0. Do you see that? See? Getting closer and closer and closer to 0. And to the left, we see a horizontal asymptote y equals to negative 1. And look at the graph. The graph is getting closer and closer and closer to this y-coordinate value, negative 1. So those are going to be your limit values. Let us elaborate this. So that's 0. And this is negative 1. Now, what if we do not have horizontal asymptotes? For example, let's change the problem a little bit, like this. Let's suppose that graph behaves like this as I move to the right. In that case, this right-hand side limit will no longer be true. That's not going to be 0 anymore. Now it's going to be positive infinity. You see, it's going up, up, up forever. How about to the left? If we have a horizontal asymptote, yes, that's negative 1, that's correct. But again, let me change the problem. What if this thing goes up again, like this? Then this will have to change. The limit value will have to change to positive infinity. Or, if this thing goes down like this, then we'll have to write as negative infinity. Make appropriate adjustment. So the conclusion, limit as x is going to negative infinity, x is going to the right-hand side, positive infinity. Those are horizontal asymptotes. Positive infinity, that's right-hand side. X going to negative infinity, that's left-hand side. Now, vertical asymptotes will give you the function value or the limit value going to positive or negative infinity. Graph going up toward positive infinity, graph going down to negative infinity, like those. So the answer will be positive or negative infinity if you have vertical asymptotes. X is going to positive or negative infinity. Those are going to be asymptotic behavior. Now, non-asymptotes, then we may have either positive or negative infinity, or sometimes even neither, like trigonometric function, sine function, just going up and down, in this case, just completely undefined. Anyway, if you have a graph, then tracking down the graph and answering the limit is not too difficult. We went through some asymptotic example here, and then non-asymptotic, more elementary example previously. Before concluding this section, let's talk about just a little bit more about commonly encountered infinities that you can do the computation kind of algebraically even. 1 over 0 is infinity, but it depends upon the sign, plus infinity or negative infinity, depending upon I'm going to 0 plus or 0 minus. You see, dividing by 0.1 or 0.001, 0.00001, things like those, are the same as multiplying by 10, multiplying by 100, multiplying by a million, kind of like that. So yes, we have vertical asymptotic behavior like this. Positive infinity, negative infinity, like those. 1 over infinity, on the other hand, is going to be 0. But negative 0, positive 0, they're both zeros. So yes, again, we can see graphical behavior like this. 1 over infinity or negative 1 over infinity, either way, y-coordinate is going down to 0. Now, some further examples on the exponential. E to the negative infinity is 0. E to the positive infinity is infinity. Graph of the exponential function. To the left, negative infinity, the y-coordinate is going down to 0. To the right, x is going to positive infinity, y is going to positive infinity. So we see that blue graph for the exponential of negative infinity and exponential of positive infinity. Now, how about the logarithm? Look at the red graph. Red is a logarithmic function, and to the right, log of infinity is infinity. This one grows very slowly, but it'll go to infinity anyway. And to the right, as I approach 0, going down to negative infinity. So log of 0 plus is negative infinity. Log of 0 minus is undefined here, but 0 plus, that's defined, and that's going to negative infinity. And then some trigonometric functions. Tangent of pi over 2, yeah, okay, here's a graph of tangent function. At pi over 2, we have splitting. So from the left, so pi over 2 negative, so that's positive infinity. Pi over 2 negative, that's pi over 2 positive is negative infinity, excuse me. Pi over 2 negative is positive infinity. I said it backward. Left-hand side limit, going to positive infinity. Right-hand side limit is negative infinity. That's for tangent. And for arctangent, we have horizontal asymptotes. So to the right versus to the left, going to pi over 2 versus negative pi over 2. They sometimes appear, but I must say they're relatively rare. Please remember, exponentials vary very well because they appear a lot. And these appear a lot too, but they're rather trivial, so very few people make mistake on it. Okay, so much for section 1. Let's meet again in section 2. See you soon.